So we'll start with Hyperledger Fabric. So Hyperledger Fabric by itself is an enterprise-grade blockchain platform. So unlike Ethereum or whatever popular technologies we have that we know of, they are just for experimentation and for the popular culture. But this is for the real pros. So actually, in enterprise-grade systems, in organizations, these type of blockchains are used. They don't support cryptocurrency or mining, but they do actually support the thing called distributed ledger technology, basically a blockchain-based database. Okay, so the design for them is permission networks, designed for permission networks. So it's not unlike Ethereum, it's not open to public. You have permissioned access to the networks, and they actually are very modular and extensible, and everything is very plug and play in sense. Like the consensus mechanism is plug and play. We can have multiple types of consensus mechanism. You can swap in, swap out consensus mechanisms, or even the database, the state database. So as we know that blockchain has two kinds of databases, right? One is the ledger database, the distributed ledger, and the other one is the world state. The world state is basically a database where all the state variables, latest values are stored, right? So that's world state. We can swap in and swap out the world state's database based on our requirements. And also it has the concept of channels. So channels are like sub networks within the main blockchain networks. So suppose, for example, we have four participants, and the four participants can have a common blockchain network to communicate with other three, and the four members can also have private channels where there will be a separate ledger maintained for each channel to communicate with. So what types of nodes are there in Hyperledger Fabric? So unlike Ethereum, there is only a single node that handles everything. For Hyperledger Fabric, we have designated nodes for designated purposes. First of them is the peer nodes. So peer nodes are actually nodes that actually are handled by the organizations, and they are of two types: the endorsing peers and committing peers. Endorsing peers, they initiate the transaction, they endorse the transaction sent by clients or users, and the committing peers, they actually validate the transactions and add it to the ledger. Also note that endorsing peers actually do simulate the transactions on the blockchain. So suppose if you are calling a smart contract, that smart contract will be actually first simulated by the endorsing peers. So here another thing that you should note that Hyperledger Fabric runs on a execute order validate sequence. So unlike Ethereum where it is order and validate, sorry, execute and order. Execute and order is the Ethereum. So no, wait. Order and validate, I think. Order, yeah, order, yeah. So in Ethereum, every node actually executes it in parallel. But in Hyperledger Fabric, only part of the endorsing peers execute the transaction using the smart contract, and then it is sent for validation. So, and there is the ordering nodes that order the transactions and handle the consensus mechanism. And finally, the certificate authority who issues the identity certificates to users and other members of the blockchain. So this is the transaction flow, how it happens. So it follows the order, execute, order, validate, or UOV lifecycle, unlike Ethereum, which is order, execute. And this is a diagram, so you can see that the transactions are sent for endorsement, endorsing peers, they endorse the transaction by executing it, and then the transaction responses are sent to the orders. And the orders the transactions in blocks, pack them in blocks, and then they send it to the validation phase where the peers, the endorsers, actually endorse the blocks and then they commit it to the blockchain. So it starts with the transaction proposal, the endorsement phase, then of course transaction proposal, the client proposes a transaction to an endorsing peer. Then the endorsement of the transaction happens. Finally, the proposal response. So once a transaction is endorsed, the response is sent back to the client here. Client collects the endorsement responses from the endorsing peers. So actually you have to collect enough endorsements from the peers so that your transaction can be validated, and that how much endorsement, how much percentage or what logic, that is based on the logic in the consensus mechanism of the orders. There are policies. We'll talk about those policies later on. And next is the ordering phase. So ordering phase, once the transactions are actually sent back to the client, the endorsements are sent back to the client, the transactions are sent to the orderer to pack them in blocks. Once those transactions are packed in blocks, the transaction validation happens. So the endorsement and the committing peers will validate the transactions, the signatures, the endorsements, everything, the certificates, and then it will be committed to the blockchain and be distributed to other peers of the blockchain. Finally, commitment, of course, after validation, commitment, and then consensus mechanism so that all the peers actually decide on a single value of the transaction and finality. So it's committed and the block is final and it is stored in that immutable ledger. So outline of this tutorial. So we'll start with installing the prerequisites. Then we'll install the Fabric binaries. Then we'll set up the configuration file. So there are a lot of configuration that we have to manage before we can actually have our blockchain running up and running. And after we have the configuration files can be consumed to create the cryptographic materials. So the certificates, the identities of the peers, users, and all. Then we generate the Genesis block again from the configuration. We consume the configuration and create the Genesis block configs. And finally, we start the network using Docker Compose. And then we create a channel for the members to communicate through. And finally, we install some smart contracts. So for installation of the prerequisites, we require some of the prerequisites like Git, curl, we get Docker Compose, Golang, Node.js. So Node.js, we have a very specific version of Node.js that we need to take care of for Hyperledger version 1.4 and 2.0. This is the version and build essentials, of course. And also we need to allow Docker to be used by our current users. So we add our user to the Docker group by creating a group named Docker, and we add the user and we add the access. Next, we have to install the Fabric binaries. The Fabric binaries are like binaries that actually help us create those configuration files, the Genesis block, the certificates and everything. It helps us automate everything. So we have to download it. Here is the release. So it's for version 1.4.4. We can also download it for version 2, version 2.2, and so on. And we have to add those binaries to the path environment variable of a system. Next is setting up the configuration files. So there are actually three types of configuration files in our system for Hyperledger Fabric. First is the crypto config. So it contains the details of the network structure, the number of users, the number of peers and everything. And it helps us create the certificates and cryptographic materials for our system. Next is the config.txt YAML. This config.txt is actually, it contains the logic and policies and everything, the details for our consensus mechanism, the application capabilities, the channel capabilities, so that one, and read-write policies of the users. So what kind of users can read, what kind of users can write, what kind of users can actually participate in the administrative processes and all. And finally, the Docker Compose YAML. So this is actually used, of course, you guys, I hope you know about what is Docker Compose YAML, right? It is used to orchestrate Docker containers. So this is the default name for Docker Compose, and that specifies all of our containers and everything that we will use to orchestrate our network. So starting with crypto config. So this is the crypto config for a peer organization. So peer orgs, and first item is org1. We set the name, the domain name, the enable node OUS, to enable the MSP service, membership service provider service, and then template. So template actually mentions how many users and how many peers will add. So sorry, users are here. Template is for how many peers we are going to have in the network. So for template, we have count one. So it means that we will have one peer per blockchain, per organization. And for that one, we have mentioned that peer1.org.example.com. That's the sans or the subject alternative names. And finally, users. So users means except the admin user. There is one admin user by default, and except that admin user, we add another user by default that is count one. That is randomly initialized. So now the crypto config for orderer orgs. So we have two organizations, base organizations, that is the peer organizations where actual the business logic and everything happens, and the orderer organizations where actually the ordering service is executed. So for ordering service, we have to mention same, then orderer name, the orderer example.com, that is the domain. So these domains are actually used to communicate with the other containers here. And enable node OUS true. Of course, we have to enable the membership service provider. Then for specs, we set the host name orderer. So finally, the sans, you see the complete domain for this to communicate with will be orderer.orderer.example.com. This is the actual domain where the orderers will belong. And this is the default orderer dot the domain. Now we have the config tx YAML. So config tx YAML, we start with the peer organizations. So the peer organizations are like this. So first we have the org1 MSP. First we mention the name of the MSP, the membership service provider. So it's org1 MSP. We can have anything, but we usually use camel casing to mention it. Then we have the ID, org1, same. This ID would be used in later point in for generating the certificates and all. And the MSP directory. So once we create the crypto config. So we showed that crypto config file, right? Once we create the certificates and everything, that crypto config directories would have the keys for the MSPs. The keys and certificates are, we mentioned the directory for the MSP, that is organization, peer organizations, org.example.com, MSP. In this folder, MSP folder, it will contain the certificates. Next, for peer organization, that same configuration is continued here. So it couldn't be fit in one slide, so that's why. So next we have the policies. So policies is where the interesting thing happens. So you see, we have readers, writers, admins, and endorsement. So we mentioned who can read data on the organization's peers, who can write data, who can process in the administrative processes, and endorsement, who can endorse. So for readers, you can see that we have to have type signature. So the signature would be required of users or peers to be validated, and rule org1 dot org1 msp.admin. So admins, peers, and clients, any of them can read. Writers, admins or client. Peers cannot write data. Admins, so only admins can participate. See? And finally, endorsement. Only peers can endorse. You see that thing that mentioned that only peers, there are two types of peers, endorsement peers and validation peers. So that endorsement, mention it, restricted to only peers. Next, we have the order organizations for config tx YAML. So we mentioned the order name, the order MSP, the directory of the MSP, and order endpoints. So we have to mention where the orderer can be reached, at what address. So the domain is orderer.orderer.example.com. You remember from the sans, you mentioned the sans in those. And finally, a port number. The port number that will be exposing so that they can communicate to other containers could communicate through. And the same file is continued here. So next we have the policies, and for readers only orderer members can read, writers same member, and admins only order admins can participate. Next we have the network capabilities. So for network capabilities we have the channel capabilities v20. That means that the channel would be supporting the version 2 protocol. If we had to support version 1.4 like this in application capabilities, we have version 1.4 true set to true. But this actually adds some backward compatibility to the blockchain. Suppose we are setting up a new blockchain and there are peers that are part of the older blockchain version 1.4. So we can actually modify the config txml so that it supports both the protocols version 2.0 and 1.4. So we have the channel, orderer, and application capabilities. Next, we have the application defaults. So you see we have channel, order, and application. So we mention further details of the application. So application defaults, policies. So who can actually execute applications on the blockchain? Policies for readers, any readers. Anyone can read. Writers, any writers. Anyone can write. Admins, majority admins. So this is where you see the endorsement and the validation comes when we are and sending the transaction for to the endorsing peers to endorse, if we get endorsements, we have to have this enough endorsements, right? And that enough is majority. So once the majority, that more than 50% of the endorsement peers have endorsed it, then only that endorsement will happen. So life cycle endorsement, majority endorsement. Same for admins, majority admins. Majority admins, if agree on something, then only it can be actually allowed. And this means that not just for any one organization, all of the organizations, the majority of the admins have to agree upon the value. And endorsement, majority endorsement. And finally, the capabilities, the application capabilities. So we actually add those application capabilities here. Next, we have the orderer defaults for config txml. So this is the interesting part. You see that we actually set the type of consensus mechanism and many other very critical parameters here. First of all is the orderer type HC draft. HC draft matlab, this is the raft consensus mechanism. We're setting the raft consensus mechanism for our blockchain. And address, the address of the orderer. So you remember that we set that thing in the previous config, that address. And HC draft, we have the consenters, so who will consent, the orderer, port, this one, and the certificates, the client TLS certificate and server TLS certificate, because all of the Hyperledger Fabric nodes will communicate through the TLS protocol for security. And we have batch timeout. So batch timeout is a very interesting thing. Suppose we have a lot of transactions coming to the blockchain, and suddenly there's a drop in the number of transactions. So if the upper limit, that is the max message count, is 1,000 here. So if the max message count is 1,000, that means a maximum of 1,000 transactions would be put in one single block. And suppose we only have 600 transactions. So if you have 600 transactions, then we'll have to wait for the other 400 transactions to come. Unless that happens, that block will not be created. So there is a timeout that even if one transaction is there and a timeout happens, that means that only single transaction will be added to that block within 999 milliseconds. So within that 999 milliseconds, if even a single transaction is there, that transaction will be added to a block and that block will be proposed to the network. And then batch size, the max message count is 1,000. Also, we have a limitation to, so even if there are 1,000 transactions, the transactions may vary in size. Some might be larger transactions, so that might actually cause problems if huge blocks are created, like GBs of blocks. So that's why we have a limitation, absolute max bytes, 99 megabytes. So absolute maximum size of a block would be 99 megabytes. And preferred max bytes, preferred is 10 MB. So it will be always preferred to have 10 megabytes. But if we don't have an option that a single transaction is more than 100 megabytes, suppose 150 megabytes, then we divide the transaction into two blocks with the absolute maximum max bytes of 99 MB. So this configuration is actually continued in the next slide as well. So finally, we have the policies for the orderer, the consensus mechanism. So we have readers, implicit meta, and any readers. Same for writers, any writers, admins, of course, majority admins have to agree upon the consensus, and block validation, any writers. Anyone can write for the block validation. We don't have a restriction that only these peers can actually participate in the validation phase. All of the peers can participate in the validation phase, but only a specific group of peers who are set as endorsing peers can endorse the transactions. Next, we have the channel defaults. So for any channel that we create on the blockchain, we have some default configurations that we set. Of course, these can be modified based on our channel requirements. So by default, when a channel is created, these policies are added to the policies and capabilities are added to the channel. However, if we want, we can later on change them. So the policies, we can have the readers, any readers, writers, any writers, and admins, of course, majority admins. That is the general rule to be followed while designing a blockchain like this. And the capabilities, so we mentioned that capabilities in the previous slide, that capabilities, we put it here. Next, we move on to the Docker Compose. So this is where we actually orchestrate, set up our containers. So first of all is the peer base. So there are two types of Docker Compose files we'll be using here. First is the base configuration that would contain a template of the container, and then there will be the Docker Compose main file that will actually contain all the logic, the ports, the volumes, and everything, the dynamic things that actually change with the topology of the network. So for base, we have the peer base. So for a peer container, we have the image Hyperledger Fabric peer 2.2. That is the image. That's the Docker image version. So this is the Docker image and the image tag 2.2. Next, we have the environment variables. So environment variables, we have the core virtual machine endpoint. Next, we have the VM Docker host config network mode. So which network it is going to connect to. So we have to create a Docker virtual network so that it can communicate, the containers can communicate within that network. So that network name, it's a default name, Docker network name. You can have any name. That depends on how you set up the Docker Compose. So by default, Docker Compose uses the directory name as well as the project name for setting up the network, but you can have anything. Then Fabric logging spec. So what level of logs are you going to append to the logs that is set to debug? Of course, it can be info or it can be warning, anything like that. Then we have core peer TLS enabled. So of course we have to enable TLS for security. Otherwise, whatever communications the peer are communicating with, that might get leaked to other peers. That's a security problem. And peer profile enabled true. So we have to set the profiles. So by default, a peer will have a user. That profile is set here true because we mentioned in that template that you remember there is a user one. That extra user is used for this one. Then core peer TLS certificate file. So that is the part to the server certificate file and the TLS key file, those paths. And then we have the root certificate file that is for the CA, the certificate authority. So every organization would have at least one peer that would be an endorsing peer and a validation peer, and also every organization would have a CA. So that would be a root CA of that organization. So that root CS certificate and the working directory. So path to crypto config peer. So whatever crypto config details we generate, those crypto config certificates and everything would be the working directory for our Docker container. And finally, the command to start the process. Once the container is up and running, we have to start the peer process by running peer node start. Then we have the orderer base. So for orderer base, am I going too fast or like it's okay? Am I going too fast? So for the orderer base, we have of course the image and then a bunch of environment variables. So for the environment variables, we have the logging spec as usual. The listen address. So at what address the Docker container would listen to? It's set to 0000 means it will listen on all interfaces. It is not restricted to one single interface. Orderer general genesis method, that is file. So the genesis would be based on a file because we will be creating a genesis file that would be used by the orderer. Orderer general genesis file, the location, orderer genesis.block. That we mentioned that at var hyperledger orderer, we have this file, orderer genesis.block, that would be a genesis file for the orderer. Then we have the local MSP ID. So that membership service provider's ID, the orderer ID, MSP. So you remember that in crypto config, no, in crypto config TXML, we mentioned the name and the ID. That same ID is mentioned here, orderer MSP. Orderer general local MSP directory. So of course the directory where the crypto config files, certificates and the keys are stored for the MSP. Then TLS enabled true as the other containers. Private key for the TLS, certificate for the TLS and the root CS for the TLS. And finally the Kafka topic replication actor. This is a hyperparameter for the Kafka service. So in the backend it uses Kafka to actually organize the messages. It is set to 1. Orderer Kafka verbose true. So of course, whatever Kafka does, the debug it will be verbose. All the details will be posted in the logs. Then cluster client certificate, that is the orderer TLS certificate, the cluster client private key, the private key of the server, and finally the root CS for the cluster. And the working directory we set same as crypto config because we need to use the keys directly. And finally the command orderer, it just runs the orderer command and the orderer starts in the block container. Next, we have the certificate authority. So it doesn't have much here. It just has image, Hyperledger Fabric CA 1.5. That is the version of the image. And the environment, the CA home. Where is the home directory of the CA process? etc Hyperledger Fabric CA server. And Fabric CA server TLS enabled, of course, TLS for everyone. So true. And the command to run the Fabric CA server, sh-d Fabric CA server start -b admin pw -d. That is the username and password, and -d for the test. So this is the CouchDB. So as we know that Hyperledger Fabric has two types of databases it supports. One is the level DB and the other is CouchDB. So level DB is a key value store like Redis, and CouchDB is a NoSQL database like MongoDB. So of course with level DB, we cannot have rich queries like we can do in MongoDB. And to support rich querying using smart contracts on our data, we have to install CouchDB and use it as a state database or the world state. So this is the configuration if we are going to use the CouchDB instance for our application. And for every peer, there needs to be one CouchDB container where the CouchDB database will be stored. So this has the image, environment, the username and password, and the ports it exposes. So it's 9844, 5894. Peer Couchbase. So these are the peer Couchbase means it actually the configuration for the peer container that we need to set for the CouchDB. So it has the ledger state database CouchDB. So if you are not going to use CouchDB in the peer container, we would set this environment variable to level DB, or we can totally skip it also. But since you are using CouchDB, we have to mention this thing here that the state database is CouchDB. Next, we have the CouchDB config address, the CouchDB4. This is actually the the address that would be put here. So this is a template, this CouchDB4, and 5894 is the port number where it's exposed. Username and password, as we mentioned here. So, and finally, it depends on CouchDB base. So unless this CouchDB database is up and running, this peer Couchbase won't be starting the orchestration. Next, we have the CLI base. So CLI base is the container from where we can issue commands and modify our network requirements, like creating a channel, adding peers to the channel, and also installing smart contracts, all sorts of administration and controlling that we have to do through the CLI container. So for that, we have the CLI base, the Hyperledger Fabric tools, that is a container name and a tag. TTY true, of course we have to enable shell. STDI in open true, of course standard in we have to enable. Environment go path. So because we will be installing smart contracts and everything, so we have to enable the go path for the smart contracts to be installed. That is go path, we set the go path, core VM endpoint, of course, and logging spec info. Of course, we are not going to set it to debug here, because if we set it to debug, a bunch of information that we don't need will be coming, and the critical information that we need for the CLI won't be showing up. I mean, it would be showing up, but it would be really difficult to find. Finally, the working directory. So same as others, cryptoconfig, and the command bin/bash. Because it's a CLI, so it will be opening the bash terminal and bash shell, and it would run. So here we have the peer config. So this is the peer config. This is not the template, the base template. This is the complete peer config for a up and running peer on the network. So it extends the peer base, the base we mentioned previously, the service, peer base. So of course the file name and the service that we are going to inherit, it extends. Environment, it has the peer ID. Peer ID is the domain name. The peer listen address is this one with the port number. The listen address 000, so it will be listening on all the interfaces. The chain code address, so whatever peer chain codes are going to be running on this peer, the smart contracts, they would be actually available on this address with this port number. And the chain code listen address, of course, again, the chain codes would listen to all single interfaces, every interface that is available to that container. and the gossip protocol. So gossip protocol is where all the transactions are distributed. So once a transaction is validated, the peers actually communicate through the gossip protocol to actually share the data. And the gossip protocol is actually set here. Where is it? Bootstrap gossip protocol. That is the port number 11132. So it has to be a different port number compared to the smart contracts. And this peer address. So peer address is the one that where the gossip protocol happens. And the external endpoint, of course, the address and the port, and the local MSP ID. So you remember that MSP ID we set in that config TXML, that MSP ID is here. gRPC verbosity. So all of the communication that happens within these nodes is communicated through the gRPC or the Google's remote procedure call protocol instead of HTTP REST APIs. So gRPC is used. So that gRPC verbosity is set to debug. In case we encounter some problems, we can find out that yeah, we had that. Of course, it can be set to whatever level that based on the requirement. And core operations listening address, that is the operations listening address that where the CLI would be connecting to the peers, that is a different port number, the same domain. So volumes, what volumes we are going to set? So Docker socket is actually one that we need to update. And the organization's MSP certificates, that directory is set. We actually create the directory using cryptoconfig, and that cryptoconfig directory is also set for MSP and TLS. TLS and MSP both we need for the certificates and the keys, right? And finally, a Docker volume is created for this name for Hyperledger production. Here, all the production files are actually stored, like the peer ledger and everything. And finally, the ports we expose, of course, 332 and 36. 34 is not here because 34 would be the port for the chain codes. But all the chain codes that are going to be on the network for this peer would use the 11134 for the communication. And finally, the network, that Docker network name mentioned earlier. For the order or config, wait a minute. So for the order config, this is the full-fledged order config for a up and running network. And we have, of course, it extends the base file and the service that it extends. Environment variable listen port. So this is a different port that it will be listening to compared to the peers because every port needs to be unique. And order listen address, of course, the address and the port where it will be listening to, and gRPC verbosity for the gRPC communication. Volumes, it contains the Genesis block. It would be updated to orderer, Genesis block, the MSP, TLS, these, and of course a volume for the production ledger networks. And what it depends on. So that orderer actually depends on all of the CAs of the organization. So if we, in this case, we have 4 organizations, 1, 2, 3, 4, and it would depend on every single one of them. Unless the CAs start, the Docker container for the orderer won't start. Find the ports that we forward to the host machine. So this is 14132 and 94443. And the network that it is connected to, the Docker network. Same for the org ca config. So ca.org.example, that's one. It extends the file, the base configuration, the environment variable, the CA name. Of course, we have to set a CA name, the certificate authorization name, that it can be used to validate the authenticity of the CA, because otherwise anyone can issue certificates, right? Anyone can issue certificates, and that would be a big problem. So we have to mention the Fabric CA CA name, the server port where it listens to, the CA certificate file. So remember that CA certificate we set in order, same, and peers, same CA for same keys are here added here. And the CA key file. So that key file is server config underscore SK. That is a private key. Ports, we have the 11135, 11135. So we forward this port to the host machine. The volumes are actually the crypto config files. And yeah, the crypto config is this one. And this is the actually the volume for the Fabric CA configuration, the root CA for root certificate for the root configuration for the certificate authority, not the Yeah. And networks, Docker network name. That is the default network we use here. And finally, the CLI configuration. So it has a bunch of information, but all of these are not very critical because these are default. You have to mention them anyways. So it extends a base configuration, peer ID, CLI. Of course, we have to add a CLI ID of this what and what peers it connects to. By default, as the CLI would connect to a peer from where you can issue the commands, a controlling center for it. And we use the org1's peer. The org1's MSP is mentioned, the TLS of course set to true, the TLS certificate and key and the root certificate, and the MSP configuration path. So for the membership service providers, key and certificates. Finally, the volumes are uploaded here. So the volumes include the crypto config directory, the scripts directory, the channel artifacts. So this will channel artifacts directory actually contains the files for the Genesis block and the channels. And finally, the blockchain contracts. So the smart contracts, we have to upload the smart contracts to this Docker CLI container from where it can be installed. And it depends on every peer and the orderer. Unless the peers and the orderers start, the CLI container won't start. And the network, of course, the Docker network name. So generating the cryptographic materials, so we use this command to generate the PKI certificates and the root CS, that is the cryptogen. So you remember that we downloaded the Fabric binaries in the previous steps. That Fabric binaries contains that cryptogen tool. So we use the cryptogen tool to generate the cryptographic materials. So we set the config path to the crypto config YAML and the output path to a directory. That is the crypto config directory. And this is like the directory structure. So crypto config, order organizations. Under order organization, we have health.com, one organization. Under health.com, we have the CA, the MSP keys and certificates. The orderers, we have one orderer, example.com, the users, admin example. So one of the users is the admin. And for peer organizations, we have the org1.example.com. We have the CA directory, the MSP directory, the peers directory, and for peers directory, we have the peer zeros directory, and finally the user, admin, and user one. So remember that we mentioned that for peer organizations, that template for user would be one, that extra user is user one. Generating the Genesis block configs. So for the Genesis block configs, we have to use the configs txgen. This is another binary that we use from the Fabric binaries to generate the. Yes, I will give some demo after we complete this. Actually, these commands, it would be a bit messy if we, yeah. Okay, no, let me just give the demo for this one. I can. So we have this sample project here. For sample project, we have this crypto config here. So order orgs, peer orgs, this config here, the configs txgen. Hmm. None of this actually. We have to write our own files. We will only have the binaries and the Docker images preferably, but all of these configuration files, we have to write it from scratch, or we can actually follow some template. There are some templates available on the internet that templates could be followed, but pretty much everything is like based on your requirements and they have to be written by yourself. So the config tx and the peer base and the Docker compose, this one. So for generating this crypto config, we have this thing here called generate.sh. So basically we have to run a lot of commands at once, like a lot of commands to just do one thing. And for that, we actually automate the process using some scripts. So for generating the network components and the configuration files, we use the generate.sh. It's a very simple file. So what it does is sets the image tag and wait a minute, just a minute. Okay. So we set the image tag. So based on the image tag, it will download the images that are need to be downloaded for the Hyperledger Fabric images, like the containers, like the peers, the CAs, and those things. And then we go to the root directory and we create a folder called channel artifacts to store the the Genesis block and the channel configuration. Then we run this command, see, cryptoconfig generate. So by default it generates to cryptoconfig folder. So this is the folder that it generates to. This command and this command is the same command. Just we haven't mentioned the output directory. We can mention the output directory or we can skip it. So if we skip it, it will create a cryptoconfig a directory named cryptoconfig in that same directory, and it will store those files in that. And once the cryptoconfig is run, we use config.txgen, and config.txgen we create the Genesis block here, and we create an initial transaction for the channel. We mention the channel name as a channel ID and channel artifacts channel.tx. So if we run this command, you see that we have these two commands, this one and this one. So one is to create the output block of the Genesis and the other is to create the channel. So once we are done with that, these are some bunch of commands to actually, you know, set the CA certificates. So these are not required here. Up to this part, let me select it. This part is not required. This is like an automation part, not part of the Hyperledger Fabric setup. This is an automation part to actually use sed and replace all of the contents of whatever private keys we have to automatically put them into Docker Compose files. And then we have this auxiliary scripts to CCP generate to create the connection profile. So connection profiles is not required at this moment while creating a blockchain network. It is required for the applications to communicate with the blockchain SDKs. We'll talk about that later on. So if we run this command here, let's go to cd basic and we can run it bash generate. So you see it did the generating crypto material for peers and generating channel artifacts and Genesis block. So it has the consensus mechanic SC draft, and these are the output info output. Writing the Genesis generating Genesis block, writing Genesis block, loading configuration, everything. So basically, blue means of course we didn't encounter any errors. However, we have one warning here, that this one, omitting chain ID for config tx, because we haven't have mentioned the chain ID, but it won't be mentioned here. And finally, the Go dependencies are installed using Go mod. So that would be also explained in the further slides. And then, of course, starting up the network. I showed you image tag set, right? Image tag. And finally, we use docker compose -f docker compose.yaml up-d. So if you have go to this script here, run.sh, it actually orchestrates the network. So there is this command, docker compose, and it will orchestrate the whole network for us, all the components, all the containers, everything. And then we have to create a channel for the peers to communicate through. So we create a channel, we specify the orderer, the channel name here, the file of the channel, the transaction that we made earlier using config.txgen, that tool, and we set the path for the TLS certificates and the CA file, root CA file. And then we join the organizations in the channels. So we set the organizations details like the MSP, the roots cert file, the MSP config path, and the port peer address, like org1. And then we run this command called peer channel join -b channel name dot block. -b means we just mentioning the block of the Genesis block of the channel. So once we are done with that, we actually move on to installing the smart contracts. So quickly, let's go through the script here. So you see after this, we have this Docker exec and create channel. So this create channel scripts in here, you see, wait a minute. This create channel script has that create, that command here that I mentioned here, create. And then it has the command peer channel join main channel, that this one. Before that, we are setting the all the details of the peers. Although this is not the most clean looking bash script, to be honest, but it gets the job done. And then we have the installation of the smart contracts. So remember that we ran the generate.sh script. That generate.sh script actually ran the go mod vendor automated. So we have just mentioned it here. In case you haven't done it yet, you can do it. And then we install the chain code. So install the chain code, same thing. We mentioned the details of the peer or organization and the peer where we are going to install it. And then peer chain code install dash n the name of the chain code, the version of the chain code, and p the path of the chain code, right? And to instantiate the chain code. So what is instantiation? So installation is basically installing the chain code as a container within the peers, but instantiation is basically calling the constructor of the chain code. So you can install on all of the peers. You have to install on all of the peers, but you instantiate on only one peer of one organization, because you don't call the constructor multiple times, right? It is initialized once. So to instantiate, we use the peer chain code instantiate, the orderer, we specified a TLS. Of course, you have to use TLS and the CFI dash V version of the smart contract. The command means the command for the constructor. So what command to use for instantiating the smart contract? Dash C channel name and dash N chain code name. So this is also here. So you see in run.sh, we have this thing called this loop. So this loop does what? It installs the chain code to all of the peers or organization peers. So like patient MSP, PHC, MSP, whatever we have organizations. And finally, it instantiates at one of them peers. So let's quickly take what these two scripts do. The install on PRCC. So we have it install CC here. So install CC, install on peer. So see the same command with all the details. And instantiate, same. So you can see here there is an instantiation thing that I can show you. That command I was talking about to call the constructor. The constructor might have some arguments. So we mentioned those arguments here. And the channel name and the chain code name. So after all of this is done, it says all done. Yes, our network is now up and running. So let's quickly run that. Bash run.sh. So once I click that, it is creating the containers and they are done. So now it's creating the channel. It takes a few moments. Let's wait. Yep. Received block 0, Genesis block. Once that's done, it actually tries. See, Raft actually tries from start to actually endorse, but it doesn't happen because the peers are not yet online, right? So that's why this error, and then receive block 0, and then created channel created joining patient. So basically now all of the organization peers would be joined to that channel. So this is 1, 2, 3. Three of them are done. Finally, another one is left. So yeah, 4 successfully done. Now it's installing the smart contract. So we have a bunch of smart contracts here in this folder called chaincode. So it has quite a few, not the GitHub one, but these 4 smart contracts. So see it installing the smart contract on the 4 peers, and it instantiated, and it's now all done. So our network is up and running. The next step from this point onwards is creating a SDK, a REST API service to communicate with the blockchain and have a front end. So let's continue with the PPT. So in conclusion, these are the conclusion. We learned about how to learned about the Hyperledger Fabric's architecture. We learned how to design and write configurations to make the network up and running. We orchestrated the network with Docker Compose, and we created a channel, installed chain codes. So what are the next steps from here on? So first of all, we have to learn about designing complex chain codes. So designing and writing chain codes is another part where you have to learn about the SDK they provide for Go, JavaScript, and writing chain code. So what are the business logics you can include? What are the how to handle the CRUD operations, everything, and also the DB and ledger queries. So of course, rich queries I mentioned about CouchDB, those things, and interchain code communication. So one chain code can also communicate with other chain code. How to achieve that? And then finally, you have to learn how to use the Fabric Node SDK. That is the SDK available for JavaScript as well as Go. And I think also for Java, they have made it available right now. So using those SDK, you can create applications that would interface with the blockchain. So you can learn how to create and import users, submit and evaluate transactions, and finally integrating with REST APIs to make a complete backend of it, the SDK as the middleware, the blockchain as the backend, and finally a front end like a web service website that would help you use the blockchain and the system. So these are the references, the paper that actually introduced Hyperledger Fabric, the transaction perspective on evaluate, order, and validate blockchains, and the Hyperledger Fabric documentation, the Fabric samples repository, and a sample project. The project I actually ran right now is actually that one, that patient emergency detection. And that's it. So any questions? And to what I do now, this line as well as yes. The project is also available on GitHub, so they can maybe oh, this one we mentioned in the slide, so that slide we can have it on the roll back. So you can go for it. In this one, you have this one on your room, and you can contact also. All those things are you can follow it.